with our next speaker, Professor Abdelkader El Kamel. I want to just point out some of his uh, massive preparation. Actually, Professor Kamel received a degree in 1990, and then he got a master also and a PhD, and he's a full professor in France. He has an habilitation to direct research from a quite prestigious university, Central Lille, in France, and he has a vast production in academic and also as a consultant in several countries, including Sweden, China, Mexico, Chile, and he is also very active in Tunisia and in several other countries. So I will ask Professor Kamel to give this very important topic for everybody, especially undergraduates, students, to grasp the experience he has in along all these years. You can present Professor Abdel whenever you are ready.
Okay, thank you very much, Professor Ismail. It's my pleasure to talk to all of you. When Ismail asked me to give a talk, I was wondering which kind of talk. So he said, can you speak about your background as a moving teacher or a moving student from one place to another? And then focus later about the cooperation to bridge between developing countries and developed countries. So as Ismail said, I am I come from Tunisia. I am French citizen now also, but I studied all my my secondary studies were in Tunisia, and I got the first prize when we finished the secondary school to enter university, the national examination. So I was offered at that time the possibility to go to the US, to Canada, to France, or to Germany. But at that time, traveling from Tunisia to France was a big deal. Going to the US was very difficult for us. I didn't know even where is it, how it works, and so on. So I preferred to go to France since most of the staff, cabinet staff, and intellectuals, and so on from Tunisia studied in France. In France, we follow what we call the selective engineering school, and I graduated from École Centrale, as Ismail explained. And then I got a PhD on system automation. Then I got the habilitation, which is required in France to become full professor. So all in system engineering. But what's important is the cooperation, because from the beginning, I am always interested in cooperation, and I am always open-minded. I want to discover new cities, new countries, and so on. So since I was young assistant professor, then associate professor, I started participating and proposing some conferences. So in 1998, I co-chaired one big conference in Tunisia, which gathered around 700 participants from 54 different countries. And it was my first big conference. Then I was involved in the board of governors of IEEE System Man and Cybernetics, and they asked me to organize the 2002 conference also in Tunisia. It was the first time that an IEEE conference take place in Africa and in Tunisia in particular. So even though 2002 was following what happened in 2001, it was very difficult to get people from the United States, but I succeeded to gather around 40 countries and around 600 participants. So when I discuss with all these people, with my colleagues from these countries, I understand the importance of networking and the importance of working together and cooperating. Because of course you can do a lot alone, but if you are alone, you are always limited. And there is some scientific area like system engineering. You cannot be alone and you cannot work alone. If you are working, for example, in theoretical mathematics, for example, or even theoretical physics, maybe you could do by yourself and keep you doing alone. If you are concerned with intelligent systems and so on, things are evolving very, very fast. I remember that in the beginning, we was trying to develop and to propose some drivers, for example, for a stupid QM, for example, the camera we find now even in a Raspberry or in any microcontroller, which is a plug and play now. But at that time, it was a big deal. For example, to upload a program from MATLAB Simulink in a microcontroller, it was a big deal, and I participated with MATLAB Simulink to find some solution to propose some kind of driver also. Now you have the C embedded C coder and so on. You have many tools. So what I want to say is that by cooperating with people, first of all, you have the opportunity to help. So that's what I tried from the beginning. I got a lot of chance to be sent by the Tunisian government to France for studying and for engineering studies, then PhD and so on. So it was my turn to help the Tunisian students first, and then I got more other cooperation, especially with China, where I am now well involved with Beihang University, what we call BUA, that means Beihang University of Aeronautics and Astronautics. And I am giving 3 full courses there about automatic control, intelligent robotics, and about mechatronics. But also, I am supervising capstone projects, which are very important for bachelor degree. So, why this is very important? Because my students in Beihang, for example, always ask me to recommend them, and many of them every year come to Europe or go to England or to the US, and I am happy to recommend them to my colleagues and use all the network I have in order to give them position and allow them to continue their studies. So, for example, last year, one of my best students from BUA, from School of General Engineering in Beijing, was admitted and now is following his master in Polytechnic Zurich, which is one of the best engineering school in Europe. Some of them, for example, are now in Delft. Some others are in Politecnico Milano. 2 of them are also in Oxford, in London. So you see, when you have a network, not only you can discuss research, but you can also discuss teaching methods. For example, I had the opportunity to develop some new technique for teaching based on what we call teaching learning by doing. That means instead of classical course, I base my course on study cases. Of course, I start with doing and giving some headlights about the course and about the main theorems and the main material of the course, and then based on a study case, we can enhance the comprehension, and the students can ask questions and be more aware about not only the theory but the application. So now I want to talk to you about some research, cooperation research. And one of the topic I am developing with my partners either in China, as I said, in Beijing, but not only in Beijing, but also in Guyana, for example. One of my first PhD students in 2007, he started his PhD and he got his PhD in 2010, was from Guyana. At that time, it was the first promotion coming from China with what we call CSC support. That means Chinese Scientific Council support. And people were asking me, why you don't select people from Beijing or from Xi'an, Canton, or from Shanghai and so on, which are much more renowned universities. I said, this guy, I see from his curriculum, he looks very good, so I want to give him his opportunity. And that was good because he smartly finished his PhD in 3 years. And now he's full professor in Guyana, in Guizhou University. And of course, we continue co-supervising master and PhD students. So this opportunity to cooperate with China, for example, outside Beijing, there is one very good laboratory, is Jilin, in Jilin University in the northeast. It's very cold, by the way, and it's not far from Harbin, if you know a little bit some of the geography of China. And they have the second best laboratory in transportation system. So we have also started some cooperation. I will explain to you some of the results and some of the topic we are developing. But I cannot forget my cooperation. Yes. Yeah. No, I will share later. This is the opening. This is the hors d'oeuvre, as we say, the general speech. And then I will share the documents about the transportation system, because Ismail wanted and asked me to talk a little bit about my way and the path I was tracking until I finished now in my. I'm not so far from retirement in maybe 15 or 20 years, or maybe 30. I don't know. Anyway. But he said that he wanted me to share with the young students the path to stress on this spirit, traveling from one country to another and trying to have opportunities with every country, with every possible country. So let me continue. And this topic I will present later is also in cooperation. I cannot forget my cooperation with Latin America, because I have very old cooperation with Chile. And one of my friends, he's also Ismail friend. He's from Valparaiso, University of Valparaiso, and I've been to Chile several times, at least 10 times, and we have organized an IEEE conference there, where I was the co-chair. So I developed this topic on robotics and intelligent transportation system, and we proposed even a European project which helped us have some kind of fundings. But my cooperation with Mexico is a little bit recent, and in 2018 I invited Professor Ismail to visit École Centrale for 1 month, and then he kindly invited me to visit Mexico. So I've been to Sinstav, I've been to Monterrey to give a talk, I've been to Mérida, and of course I was to Chichen Itza, and I profit from Tulum and from some touristic activity beside research. Because, you know, when you do research, you have also to have open spirit and to be relaxed. So it's important to combine good food, good drink, good friends, and of course, hard working. So it's a combination of all of them. So now let me share with you the presentation and the topic I want to share with you. So, as I said, there is the teaching and supervision of undergraduate students, as I said, either in Tunisia in different engineering and business schools, either in China. Actually, I'm doing it through Zoom since there is a travel ban to Beijing for 2 years now. But it's rather working pretty well, and the students are hardworking, and things are doing pretty well. In research, I want to share with you this topic about optimization and decision-making in intelligent transportation systems. Of course, I will not bother you with technical developments and mathematical developments and computer developments. I will give you just an overview because Ismail asked me to be brief and, of course, to give more headlights about the direction. Maybe some of you could be and would be interested later after graduation, after bachelor, maybe to pursue in master and in PhD. So, for example, this topic I'm sharing now with Ismail, and we have some students working with us, and we hope to select PhD students and have them partly study in Mexico and partly in France. So, since I can receive them for short periods. So there is a kind of dynamics, and we try to bridge the gap between our two countries and try to have joint supervision and on mutual topics of interest. So let's talk about optimization as and the decision making in intelligent transportation systems.
Yeah, if you put in the slide mode, please, Professor Abdel.
Yeah. It's okay now?
Yeah, perfect.
Okay. So I will give you some background to explain why we are concerned with this topic. Some, of course, this is mainly for student undergraduates or even master students to have an overview about the topic, why we are talking about, what's the interest, and so on. And I will give you some of our topics we are developing and some of the results. For this topic, for example, because, you know, when we are concerned with intelligent transportation systems, that means we are concerned with vehicles. So mainly we are concerned with these intelligent vehicles. But if you consider a platoon of vehicles, this is something in highway or in the urban traveling or as we will see in robots. And it's a kind of intelligent robots which must be autonomous. And of course, there is some kind of specification, but we can see the vehicles either as transportation system or as robots which are involved in transportation. For example, I work in logistics, and we are developing some solution for robotics and for robots to carry some duties and some job for manufacturing system. So these robots, of course, they can be seen also as vehicles. By the way, now I am generalizing this topic with my friends in China in particular, and we are working in UAV. That's UAV and UJV. That means unmanned ground vehicles and unmanned aerial vehicles, and the combination between the two kind of vehicles. But Anyway, this is just to inform you that it's possible to go further and to extend. You are not limited necessarily to ITS and the transportation, basic and the transportation. So, of course, today road transportation, there is a lot of problems. So what kind of problems we are facing? Most of all is the traffic congestion and all what's related to vehicle emissions. And as you know, with the COP21, COP25, 26 now, all states are trying to limit the emissions and to reduce pollution. And there is stiff standards in order to get rid of, as possible, of these problems. So, what kind of solution we can propose, and what are the problems related to these classical the classical vehicles? This traffic and congestion will most of the time will cause accidents. And why? Because most of the time, if you look to the statistics, there is problem with the driving behaviors. For example, the driver are drunk or sleepy or so on. So most of the time, it's a human factor. But there is also some problem of non-respect of signal timing, signal lights, and so on. So both of them will cause injury, low capacity in the roads, and of course, time and fuel consumption and pollution. So what can we do to cope with this problem? Especially nowadays, our planet is dying and we have big problem if we don't reduce this pollution. So if we look what's happening in the transportation in different countries, we will see that there is unbelievable an increase of vehicle volume and extension of road network. Here, I will give you just some statistics about Europe, as you see in the map. Here, for example, in the United States, China, and France. But I can tell you, for example, in Tunisia, when I left Tunisia in 1985, you can have maybe one family out of 10 have a car. Now and nowadays, in each family, in average, you have up to 2 cars. So you can see for a small country like Tunisia with just 12 million of inhabitants, you see the increase of number of vehicles. So of course, in China and in the United States and in Europe is a big deal and a big problem we have to cope with. So what can we do to deal with this problem? First of all, and something which is underway now, is to use what we call the IoT, that means the Internet of Things. And a vehicle, we will see, will be something, some kind of entity, and we will deal with this vehicle, and we will try to put some intelligence and some equipment, so the vehicle becomes more smart and an intelligent vehicle to behave in a kind of a platoon with the other vehicles. So, and we can also propose some realistic traffic prediction via what we call the vehicular mobility model. What's the meaning of that? The problem is that if the congestion, if there is some, for example, some breakdown or some problem in highway, if we are not able to react, the problem increase exponentially. So if we are able to have some prediction and to have some mobility model in order to predict and to anticipate this kind of phenomena and this kind of problem, it becomes much easier to handle and to cope with. Okay, I will not develop this part because most of you are now familiar with the Google driverless car. You know, now some of them are operating in different countries, so no problem. The Tesla car, even though you heard, I don't know if you heard, 2 weeks ago or maybe 10 days ago, we had a very bad accident of a Tesla car in Paris. So all the Tesla are now are not allowed to drive until the end of the investigation to see what's happened. Is it driver mistake and error, or is it the embedded system crash or failure? But anyway, later the purpose is based on intelligence. That means multiple sensors like video camera, ultrasonic sensors, front radar, GPS, and so on, to be able to deal with emergency braking, collision warning, cruising, lane changing, collision avoidance, and so on. This is in theory, and of course, the problem is, as you know, that when you have an accident, one accident hour out of 1,000, all the media will talk about, because it's new and it's autonomous vehicles or almost autonomous vehicles. So, but in average, if you see the number of accidents caused by driver and human, there is no compare what's happening with human to autonomous vehicles. So, and it was the same fear we had in the past. I remember when I was young and I traveled the first time from Tunisia to Paris. Of course, we had at that time the Boeing 727 and 737 with three person in the cockpit. Not only the captain but the captain in second, and the technician. Of course, when they switched to Airbus and to automatic the plane, there were a lot of strike. There were a lot of problem in the transition stage. Of course, now nobody remember that, because everybody knows that the plane are in autopilot and it works pretty well. And most of the time, if there is any accident, most of the time it's due to human, not to the technology, or a combination between both of them anyway. So why we need cooperative intelligence? We need cooperative intelligence in order to improve the interaction among these actors in real time. And this is a big problem for you students if you are concerned with computer engineering. Real-time problems are much more difficult to handle than offline problems we can solve and then we implement. To enhance also the learning ability, in order that the process becomes almost fully autonomous. For the moment, it's not. We are there is 4 levels. We are in level 3. The car is requires a driver to be in and to take back the driving if there is any drawback or any problem or any incident. But anyway, so the purpose is to have this learning ability and self-adaptation and control of the vehicles. Of course, the purpose is to improve the safety and the efficiency, because most of the time, autonomous vehicles are less consuming, are smoothly evolving, and the performance are much higher than human vehicles. So if you see here, I put this on purpose to show you that ITS, or intelligent vehicles, or intelligent autonomous vehicles in general, and intelligent robotics in particular, is in the cross line between different technology, different discipline and domains. So you can say, you can find, of course, sensors, because you have no intelligence if you have no sensors, and multiple sensors. By the way, we most of the time we do what we call the redundancy. That means we put more sensor than required for the reliability of the system because of safety and security standards. We have all what's related to information technology, computer science, because most of the time all these technology are embedded and you need algorithms to handle and to drive this this process. The control in order to have autonomous pilot, and of course the communication if you want to have interaction between the different actors. So it's let's say an economic and management problem. Why it's economic? And I stress on the economic because most of the solution need you to focus on the cost, and you cannot implement solution without looking to the cost. So it's an economic and managerial problem. So managerial, that means you need some decision, for example, to build autonomous highways, to allow autonomous vehicles to be moving in a city and so on. But you need also the economic because it costs a lot of money, at least in the beginning. Later, when you increase the scale and you develop multiple vehicles, of course, you have much more you decrease the costs and the prices. So, as we can see here, from a conceptual point of view, we have the interaction between users, roads, and vehicles. And the purpose is to improve not only the efficiency, but by keeping comfort and standard of comfort and safety with environment conservation, and this allow to have new industry and new business. For example, sometimes I participate to some engineering training periods as a supervisor, and I see the subject that are proposed in Europe and in France in particular, and many students are now working in this domain, and there is a lot of opportunities in this domain. Of course, when I say in this domain, in intelligent transportation system, in general, that means if you are able to understand and to use in this particular domain, of course, later you can duplicate and you can capitalize the knowledge and use it in other domains, because these are really multidisciplinary and very difficult and very complex systems. So, what are the major research interests? And Ismail, don't worry if you are approaching the dead time. You tell me in advance because I have so many things to say. So you not tell me 10 minutes before, so I can skip some slides. You know.
You have 5 minutes, please.
Just 5 minutes.
Sorry.
Give me 10 then.
Okay.
Okay, I will skip. Let me or at least give the main topics for the student to be aware.
Yeah, please.
Yeah. So what we call the V2x technology. That means what is related with vehicle, with infrastructure. So this is very important, and we are developing some solutions, many solutions about V2V and V2I. That means vehicle to vehicle and vehicle to infrastructure, using, of course, the Internet of Things. But there is something very interesting also is the virtual reality. When I started my cooperation with China, and China Beihang University are very known. They are number one in aeronautics. And at that time, they showed me some scenario for flights fighting. It's for army, but they show me just some part, and I was impressed. Of course, we couldn't cooperate in the military, so we decided to cooperate in vehicles. And I tried to develop many solutions by applying some virtual reality, some augmented reality. Now that means the connection between virtual world and real world, which is beyond simulation. So I will not give a lot of details, just to show you what kind of domain and what kind of application we are considering. I have 15 students from China who already graduated with PhD on these topics. So almost 1, 2 or 3 in each subject almost. So platoon control in urban condition, autonomous intersection management, and virtual reality simulation platform, and predictive vehicle management system. So without entering in the details, if you have question, I can explain rapidly. Intelligent vehicles are vehicles who are able to combine the longitudinal control and the lateral control. That means longitudinal control, that means to keep a secure distance between vehicles, and the lateral is to keep the line, what we call line keeping. The control in urban conditions, most of the time, ACC, which is adaptive cruise control. This is the classical one you have in your cars. But now we have different solution about what we call cooperative ACC, which is an extension, we extend the basic ACC. And then the application on intersections. Why in intersections? Because one of the problem is that we cannot build new highway, and we have in Europe big problem with intersections. So if we can handle this, it will be a good deal. So without entering into details, this is the idea. This is classical system. And what we want is to have a system which is automated. That means here, as you see, for example, here, you have the cars which are arriving in their lines. And here, this is what we call the decision area. And then after a decision management system, it will allow the vehicles to move from one to another place. So this is a combination between a vehicle and a management system. And I don't know if there is what we call now the automated metro, for example. The first one was built in Lille in France, and then they exported to US, to China, I don't know, in Latin America, but this is the same idea. That means instead of having a train, classical train, you will have an automata, and you will have a management system which handle this. So this is the idea for these intelligent vehicles. So maybe I will not go further. Maybe let me show you how it works. Later, if you want, I can give you more highlights, especially how we use now deep learning and Q-learning and database management system in order to make the system more intelligent and more reactive and so on. Let me show you just, if you want, let me show you some simulation, if I can find them here. Where is it? Here. You can see the simulation?
Yes, it's possible.
You see? So this is some simulation about the automated way. Of course, there is a processing system, management system, and the vehicles arrive randomly, and they form this kind of platoon. This is part of the work of one of my PhD students called Bing Liu, who got brilliantly his PhD, and it gives you some idea about this system. To conclude, what I want to show you is that we can do a lot of technology with application to important problem, to cope with an important problem which is related to our way of life, to our environment, and so on, and to the costs also. Energy is getting very, very expensive. In France, we got some strikes and problems due to the prices of gas and so on. So you see, and even in Europe. So if we can save this and save our planet, it will be a good progress. So this is an opportunity for you as students to focus on this kind of domain and on this kind of applications. Okay, I let some room for question and answer, maybe, which is maybe more interesting to react and to answer your questions, if you don't mind.
Thanks, Abdel. Just let me talk a bit Spanish for the general. Estamos ante esta presentación bastante interesante, sobre todo lo que quiere compartir el profesor Abdel, pues es su experiencia, ¿no? De venir de un país como Túnez, en África, compartir su experiencia y cómo ha logrado hasta este momento pues, ser líder de investigación en esta era de Transportation Systems, ¿no? Vehículos autónomos. Y bueno, pues la sesión está abierta para las preguntas que deseen hacer, ¿no? Ya sea si quieren abrir su micrófono o bien por el chat, como ustedes gusten.
Any questions?
I'm going to start, Professor Adel, while they're preparing. This is important, especially because humans, react between 100 and 200 milliseconds. What we will expect in the future with what will be the speed to respond in new scenarios with autonomous vehicles? What will you see the challenges of this?
There is two main challenges. Of course, there is something very important, as you may see, is that this topic involves sensors, and sensors are changing all the time. And this is by itself is a challenge to be aware and to keep aware. That's why I involved engineers and student engineers in our research in order to keep an eye about new developments and new technology. This is something very important. But there is other challenges which are very important, is what we call now, and we are developing the driver in the loop. That means not only the vehicles must be autonomous, but we have to include the driver behavior, and because we don't think that it's possible and feasible and acceptable for the moment to have fully automated vehicles, at least in urban conditions. So there will always be a human. So that's why we want, and we are developing some results, and we have a nice journal paper which was published 1 month ago in IEEE Transaction on Vehicular Technology, where we deal with the human being in the loop. So this is very important. And of course, it needs, beyond all the technology, you need to talk with people on psychology, because there is the psychology, the human behavior, the human feelings, and so on. So this is very, very amazing, because we talk to other people in other fields. So you see, this is cooperation, not only cooperating with people from other countries, but cooperating with people from other domains to understand what's going on and to consider their point of view in the loop. So this is very, very challenging and very important. And of course, Ismail, as you know, since you was a jury member in my latest thesis, is all about the deep learning and all this deep learning methods, how to include them in order not only to give robustness and improve the control, but to use them in a predictive way. And we had some joint cooperation research on predictive control based on deep learning, Q learning, and all the data we can get from the sensors, from the infrastructure, and so on. So I think these are the two main challenges in the future.
Yeah, thanks. We're waiting for a question. Let me. Yeah, there's one question. Please, Professor Nimrod.
these vehicles are normally supposed to be working without driver. And we have some experiments in China because it's much easier and cheaper to get equipment. We have 3 vehicles, equipped vehicles, and we have some scenario, and we are able to travel around the campus fully autonomous vehicles. Of course, due to avoid any risk, as I said to you, if you have one accident with Tesla car, all the world will hear about it. But if every second you have an accident with normal car, so that's the drawback. So that's why we need to keep a driver inside, or to keep someone who is ready to stop the autonomous vehicles in our tests during during our tests in the campus. And in Lille, for example, we have now one vehicle which is fully autonomous in our campus, and it has different stops, and you can it's a kind of mini bus, and you can, when you want to go from one part of the campus to another part, but it's a little bit limited because it's the stops are already programmed and they are known in advance, and there is no way to stop the vehicle unless of course there is a monitoring system, but everything is known in advance. What's more complicated is when you have unpredictable and of course when you have uncertain environments in real condition, this make a big difference.
Okay, thanks, Professor Abdel. And now it's the turn of Jose Francisco. Please.
Hello, Doctor.
Hello.
I have one question which is not related to the topic exactly, but mostly for the cooperation. You said you had 15 Chinese students?
Yes, who are already graduated.
And
yes.
I wonder if you are working in Europe, in a university in Europe, or?
Yes, I'm working in Europe.
In Europe,
so yeah,
which is the? Oh, I'm sorry. Where do you have the funding?
Let me explain to you rapidly. Yeah,
okay.
Yeah, because it's an amazing situation.
Yes.
It's not very common.
Okay.
Normally, the topic is this one, but I said when I seen the other topics, there is more technical. So I said I will combine both of them. I will talk about cooperation, and I give the framework, for example, on ITS. This is the idea. But anyway, so what happened is that when I got my habilitation, I am allowed to supervise by myself PhD, because it's required to become full professor in France. It was in 2000. I had Tunisian students in the beginning, but since 2005, I started a Chinese Scientific Council sponsored cooperation. My first visit to China was in 1992. I'm amazed sometimes to say to my students, I know China before you, because you are only 22 years old now, or 2022. They are bachelor or third year, and I know China before they were born. But anyway, so these students come to France for a PhD with the support from China. So I had up to 2 to 3 PhD students. Now there is a little bit some, the geopolitics and so on. There is some restriction and limitations. So it's not as easy as before, but I keep cooperating with my Chinese. Since I'm supposed to go there up to 6 months a year. Since I do my teachings in second semester, most of the first semester I spend it in Beijing. So except for 2020-21, because of the COVID, but this is my schedule. And next year I am supposed to go there for 1 year sabbatical. So of course, I have some PhD students who are working in China. That means either in Guizhou University in Guyane, or in Xi'an, Jiangtong, or in Beijing, or in Jilin. So I have 2 master and 2 PhD. And I supervise them through Zoom for the moment. And of course, since I go there for teaching, I combine teaching with supervision, and now it becomes I have one PhD every two years or 3 years because of some limitation.
Okay, thank you. And do you think it's possible to have a cooperation with Mexico?
This is what I am saying to Ismael. I am crying all the time. Hello, Mexico. Yariba, yariba. We want cooperation with Mexico.
We have now.
Yeah, when I came to Mexico.
We have now funding from CONACYT.
Yeah.
For cooperation between France and Mexico right now.
Yeah, I know. So I know. This should be a possibility to start. I said that when I came to Mexico in 2018, I was supposed to come every year, but in 2019 I had some. I was obliged to go to China, so I skipped, and in 2020 it was too late because of the travel ban. But I have this cooperation with Ismael, and I told Ismael that I don't like to stay only in Sinistav. I would like to travel, first of all, to see and to visit the beautiful country you have, and also to meet some also friends from and colleagues from other universities. So that's why I gave one talk in Mérida, and I visited this part of Mexico, which is fantastic. And I gave also a talk in Monterrey University. I was supposed to give a talk in UNAM because the professor there was involved in our European project, but due to some arrangements, it was not possible. So for me, it's very important that we start, and we can start by choosing master and PhD. And I said and Ismael knows because I involved him in several defenses. In France, 3 years PhD. So not 5 years, because sometimes I'm astonished when we have a master student say spending 2 years, 3 years, 4 years in master. For me, this technology, these problems are evolving so fast. So if you keep your time and you take your time and speta and relax, take it easy. The problem is your research in the starting point could have nothing to useless in the ending or in midterm. So you have to go fast, of course, and fast and not fast and furious as the movie, but fast and serious and seriously. So even if my PhD students spent 3 years, all of them got at least 2 journal papers, and most of them are in IEEE ITS or an IEEE and Vehicular technology. That means Q1 or Q2. This is no more. I refuse to publish in Q3 or 4. So what I mean is that there is a dynamic with Ismael. I would be interested to extend this dynamic with other colleagues from Mexico, and I will be happy to come back to see you and to invite you to France and to bridge. And this is why I accepted this talk, because there is opportunities, and for me, I am willing to help, supervise, co-supervise, and write joint papers, high-level joint papers.
Excellent. Thank you very much, Professor Abdel. Thank you.
Yeah, thank you. I have something to say to you. Now, in my career, even I am young. I'm not that old, by the way. Yeah, I'm a little bit older than Ismael, not that much. But I skipped many, and I was a little bit fast. So I think that now I reach a level that I can choose with whom I work, in which domain, for what. So I can choose, and I am, of course, Mexico is in my top priorities.
Okay, thanks, Professor Abdel. I will share the details with Jose Francisco, and at that time, so unfortunately, it's gone, but we'll talk again, sure, very shortly.
Okay, Thank you for listening to me. It's always very short. Huh? I have so many things to say, but this is only the beginning, and the show must go on, as we say.
Thanks. See you.
And the last thing in Spanish, pasito, pasito. Bye-bye, and thank you for your invitation.
Thanks for the cooperative.
Bye-bye. Take care.